All right, so in this example, what we'll see is that methods 2 and 3 both have shortcomings. So um, let's think about this hypothetically here. All right, so if I use method 2, I'm going to get a u dot. And that's not okay. So that would say, okay, let's switch to method 3. But what would happen is if I do method 3, PFE, or partial fraction expansion, doesn't give a first order breakdown. In fact, we have complex roots. So the systems aren't first order or can't be decomposed to first order. All right, so what do? Well, what we can do is we can break this down into smaller parts. And what we can do is say, well, we know that y over r is equal to s plus 2 over s squared plus 2s plus 2. But why can't that be equal to s plus 2 multiplied by 1 over s squared plus 2s plus 2? Because we fully know how to work with that. All right, so we definitely know how to work with that. And let's call this part y over q. And let's call this part q over r. Okay, and we can actually do some things that we know how to do in this case. So let's look at what this looks like in a block diagram form. Now I would have r here. I've got 1 over s squared plus 2s plus 2. And then in between this, let's call this q. And then I've got an s plus 2 gives me y. Okay, so let's start with q over r. All right, with q over r equaling to 1 over s squared plus 2s plus 2. I get the following. I'm going to get q double dot plus 2q dot plus 2q is equal to r. And what we'll do is assign states in the following way. Assign x1 is equal to q, and x2 is equal to q dot. And what that means is that x1 dot is equal to x2. And it also means that x2 dot is equal to q double dot, which I can solve for. We can get q double dot is equal to minus 2q dot minus 2q plus r. And we can sub our state variables. So this is x2 dot is equal to minus 2x2 minus 2x1 plus r. Okay, so that gives me the x equations that I need. Now I just need to figure out y over q. So let's look at y over q, which is equal to s plus 2. And what we can do is cross multiply this. All right, y is equal to sq plus 2q. So little y is going to equal to q dot plus 2q. And I have state variables for this. Y is equal to q dot, which is equal to x2. and plus 2q, which is 2x1. All right, so now my collected expression together, x1 dot, x2 dot is equal to something times x1, x2 plus something times r. And let's start with the output equation because it's really the easiest. Y is equal to 2x1 plus 1x2 plus 0r. And then let's remember the x1 and x2 dot equations. So x1 dot is equal to 0x1 plus 1x2 plus 0r. And then x2 dot is equal to minus 2x1 minus 2x2 and 1r. Okay, so that gives me my whole state space representation. And that was really just a kind of a combination, if you will, of methods 2 and 3. So that constitutes method number 4.